Hello and welcome to lesson 7.6 Hidden Identities. We're gonna have some mystery going on today. Um okay. So use the diagram to help you find the two angles between 0, not including, and 2 pi that are two solutions to the equation. Okay. Round your answers to 2 decimals. So we want to use 2 decimals. It's important to read the directions, and your calculator should be set in radians. Okay, so before we start, let me just make sure that I follow directions. My mode should be in radians, right? So if you are in degrees, you should toggle off to radians. Okay. Okay. I'm not gonna go through the example. You can do that on your own time if anything is not making sense. But let's kind of jump into number one. So I have sine of theta is equal to 1/6. Okay, what does that mean? That means that sine of theta is 1/6, right? And I want to find theta. I want to find this. So we should feel comfortable solving for this, right? So to get rid of sine, I do sine inverse. What I do to one side, I do to the other, right? Good. So theta is equal to sine inverse of 1/6. Okay, so that is directly my first calculator value. Let's hop on over. So I do second sine, right? So sine inverse of 1/6. So that is equal to 0.167. They said 2 decimal places. That's what they said, right? They said 2 decimal places. Let's use the calculator value as a pretty let's do 3 decimals for that one. Okay, so now we know that one of these angles is 0.17, 2 decimal places, so you can just say that this is 0.17, right? Okay, so then 0.17 in this circle is like somewhere here, right? So that means that this is 0.17. Now you have to ask yourself, my calculator gave me this value, right? But your calculator is not smart enough, right? Um, because sine is positive at two different locations, right? Sine is positive here and positive here. So I need another angle that where theta is equal, sine of theta is 1/6, so somewhere here. Okay? And now what value, sorry, this is not a 1. This is just like showing you that this is the angle here, right? So then what angle is this right here? What do you think? It's also going to be what? 0.17. Okay? But I don't want that angle. I want this entire angle from here to here. I want to know what this measurement is. Okay? So how would I do that? So again, let's talk about this a little bit. So on the diagram, we found that this was 0.73, right, for this example. Now they add that reference angle and the angle of rotation to the diagram. So the angle of rotation, it starts 0 and it goes all the way around. So for us, actually, let me make this clear. We start here and we go all the way around. So how would I find this entire thing? So my second angle would be 3.14 minus 0.17. Okay, so 3.14 minus 0.17 is 2.97. So my two angles should be 0.17 and 2.97. Okay, So here and then here. This is 0.17. This is 2.97. Okay. So again, my calculator value is only one number, right? And right, that's not what I want. I want to have two. Okay. Okay. Let's talk about number two. So here we have same concept, right? So how do I get rid of sine? I do sine inverse. What I do to one side, I do to the other. So sine inverse of square root of 2 over 5. So let's crank this out. So I'm going to get sine inverse of square root of 2 over 5, which is equal to 0.286 to 0.287. So 0.287, which we can just round this off to 0.29. So really quick, I know that one of these angles here is 0.29, and then same concept here, right? I know that sine is positive in quadrants 1 and 2. This is a positive sign, right? So there should be two answers there. Two answers there. And I know that this is 0.29, this right here is 0.29. So to find my angle of rotation, to find this, we do pi, 3.14, minus 0.29, okay? And that is equal to 2.85. So my two angles are 0.29 radians, and then 2.85, okay? Let's talk about number three. Okay, now we have negatives. So this should be a big key that we're going to be under what quadrants. So let's kind of copy this and then let's paste this here. So now we have a negative sign, right? We're talking about a negative territory. So now we are down here, okay? So again, we're going to solve this the exact same way. So sine of theta is negative 8, 9. I'm going to do sine inverse on both sides. And theta is equal to sine inverse of negative 8, 9. Okay, and we're going to go ahead and plug that into our calculator just the way we see it. Sine inverse of negative 8, 9. And then what do we get? We get negative 1.09. Negative 1.09. So this is negative 1.09. Okay, so that's exactly what it is. Now, I want to find positive angles here, right? For some reason, I don't really want to know the negative ones. So let's kind of just ask ourselves where we think that negative 1.09 would be at. So it would be somewhere here, right? And how do we know that? Because if I go, so I'm gonna, if I go counterclockwise, if I go clockwise, going clockwise, you'd get something like this. So going clockwise, this would still be 0. This would be negative 1.57. This would be negative 3.14, negative 4.71 if I was going clockwise, right? So somewhere, I should be somewhere here, okay? Now, we can do that by adding what? If I think about a coterminal angle. So a coterminal angle means that I'm adding what? I'm going to get negative 1.09 plus 2 pi. So let's kind of go here plus 2 pi. And I'm doing this two different ways right now. I get 5.19. So 5.19. So my angle here is 5.19. It's my first angle, okay? Now, how much is this difference? How much is this? Well, and let me make this more just scale, just because I think of it. If it's 5.19, I'm somewhere here, closer to here, let's just say 5.19. So this angle is how much? 1.09. Theta here is 1.09. Okay, so then let's think about this over here, because I have two sines. Sine is negative in two quadrants. So right there is my one angle. And then how would I find this angle? Okay, so how much is this right here? 1.09. So here, instead of subtracting pi or theta, I'm going to do 3.14 plus what? Plus 1.09. Okay, and that is equal to 4.23. So my two angles are 4.23 and 5.19. Okay. So I did this using the coterminal angle, which is equal to 5.19, right? Coterminal angle. If I didn't know how to find a coterminal angle, you could have done this differently, right? So you know that negative 1.09 was my angle, right? So then this right here is positive 1.09 technically, right? So then this is also equal to 2 pi 6.28 minus 1.09. Okay, and I think that those are um the same. So let's kind of just do it to double check. It should be pretty much on par with that. 6.28 minus 1.09. 5.19. Yeah, good. So we got the same answer, right? Okay. And that is because sine is negative at two different quadrants, right? Quadrants 3 and quadrant 4. Quadrants 3, this is 1, this is 2, this is 3, this is 4. Okay. Let's talk about number 4. So for 4, something very similar, we have that theta is going to be equal to what? Sine inverse of negative 3/8. Okay, so this is sine. So let's go to our calculator. Sine inverse of negative 3/8, close the parentheses, negative 0.384, negative 0.384. So this theta here is negative 0.384. Okay, which can just be rounded off to negative 0.38. So, okay, so let's do this. So sine of theta is equal to negative 3/8. So then theta is somewhere here, right? And I know that this right here is 0.38, right? And that's kind of what it is. If I'm going clockwise, right? Okay. Now I want to know this position is positive, so then I could do 6.28 minus 0.38, which is going to be equal to 5.9. So this is one way. This is my first angle. Or if you like doing it the other way, you can do using a coterminal angle, negative 0.38. Now that's here. How do I get the positive version? I add 2 pi. And I actually like this way a little better, just because I just think that coterminal angles are a lot more simpler, or a lot easier, I would say. So then I get negative 0.38 plus 2 pi is 5.90, right? So I get the same answer there. That's 5.9. And then there's one location here, so my other location is somewhere there. Now, how do I find that location? So again, you should pick up on that this is 0.38, this right here, right? Because these two are congruent, or no, not congruent, but they are, yes, congruent. Same size, same shape, same angle, right? So then I would add. So 3.14 plus 0.38 is equal to 3.52, right? So I have my two angles are 3.52 and 5.9. Okay, those are my positive angles because they wanted us to get angles that were between 0 and 2 pi. Okay, between 0 and 2 pi. Good. Okay, so number 5 is going to be a little bit messy, I would say, just because there's a lot of algebra there. I'm going to add a page and I'm going to try my best to not make it so messy, I would say. But a lot of this is going to be messy, I would say. So so my identity that I care about is, right, so this is my sine of theta, cosine theta, and then I need to find tangent of theta. So to be good here, I'm going to take sine of theta. So what's sine of theta? Square root 3 over 2. I'm going to square this plus 1/2 squared. And this has to be equal to what? Right? So we are verifying this identities. We're trying to verify this Pythagorean identity. Okay? So we want to make sure that it is equal to 1. So let's kind of do it. So here we got that this is square root 3, and I'm gonna write this one out because we might get confused as to how to do this, which is totally fine. But this is, remember, becomes square root 9 over 4, which is equal to 3/4, right? So the square roots go away. So here these square roots kind of cancel. So you're just left with 3. So then I'm left with 3/4 plus 1/4. So that's true, right? That is a true statement. And now tangent of theta. This is important. I'll write it over here. I know that tangent of theta is equal to sine of theta over cosine theta, which is equal to y over x. Okay, so think about sine as your y coordinate and cosine of theta as your x coordinate. So then tangent of theta here, so then tangent of theta is equal to square root 3 over 2 divided by 1/2. Okay, now we cannot forget how to divide fractions, right? So it's change the sign, and then flip the fraction. So this is just equal to square root 3. Why? This goes away there. Square root 3 times over 1 is just square root 3. Okay, so this is square root 3. I'm just going to kind of copy these down, and we're going to kind of go from there. Okay. So again, this is sine theta, cosine theta, tangent of theta. Okay. So then my identity, try to memorize the identity. It's sine squared, so negative 3/5 squared plus 4/5 squared has to be equal to. So here, I'm going to get that this is 9 over 25 plus 16 over 25, which is equal to 25 over 25, which is equal to 1, right? So if it equals to 1 is a true statement. So that's good. So that does fulfill the identity. And then tangent of theta. So tangent of theta is going to be equal negative 3/5 all over 4/5 is equal to, can't forget how to divide fractions. So negative 3/5 dividing this by 4/5. Remember, change the sign, flip the fraction. These go away, negative 3/4. Okay, very nice. Negative 3/4. So I'll write it here. Negative 3/4. Good. What about C? Copy. Let's go So same concept. This is sine of theta, cosine theta, tangent of theta, right? So this is just kind of what it is, right? You kind of follow it. So you need to verify the identity. So sine of theta, so negative 513, you're squaring this, plus negative 12 over 13 squared has to be equal to 1. Okay, has to be equal to 1. So let's verify that. So this is 25 over 169, okay, plus 144 over 169. So this should be 169 over 169 equals to 1. True statement, right? So we verified that. And then last but not least, tangent of theta is equal to negative 5 over 13 over negative 12 over 13. Okay, so this is equal to negative 5 over 13 times negative 13 over 12, which is going to be equal. This goes away. I'm left with 5 over 12. Okay, halfway done with this. And so far, all of them have fit our condition. Let's talk about number, well, not a number, but, oops, add a page. It's not gonna let me do it right. Okay. Let's try this again. I did something wrong. Copy, paste. Okay, so this is sine of theta, cosine theta, tangent of theta. Okay, so we're trying to verify the identity. So my identity is sine of theta squared plus cosine theta squared has to be equal to 1. Okay, so then let's kind of do this. So here, remember, the square roots go away, so I'm left with 14 over 49, okay, plus the square roots here go away, 35 over 49. So this is equal to 49 over 49, which equals 1, which is a true statement, okay? Very nice. Now tangent of theta, again, is equal to sine of theta over cosine theta, which in this case is equal to 14 over 7, dividing this by square root of 35 over 7. So doing this out over here, doing it the long way, so in case you are struggling, right? So I'm going to keep, change, and flip KCF. So square root of 14 over 7 times 7 over square root of 35. These 7's go away, and I'm left with square root of 14 over square root of 35. Now, this is a little bit more of just an algebra trick now, where I can write this over a square root of 14 over 35. And I can simplify this inside, so it becomes square root of, I divide by 7, so by 7 by 7, so I get 2 over 5. Can I do that? Yeah, I can, right? Let me just verify that that's correct, because that seems like a big jump, but yeah, but I can do that. Totally allowed. So I get this is equal to square root of 2 over square root of 5. I don't usually leave this in the bottom, so I'm gonna bring it over here, square root of 5, multiplying it the top and the bottom by the denominator. This is square root of 10 over 5. Okay, so this is my tangent. Good. And now let's talk about, so let's do -1 and 0 here. This one's not terrible. So then sine squared is going to be -1 squared plus 0 squared equals to 1. That is a true statement. Yep. Now what's tangent? So tangent is going to be equal to -1 over 0. So that's not possible, right? This is a red flag here, red flag, because this is undefined. So it's undefined because we cannot divide by 0, right? So tangent of negative, so tangent at 0, -1 is undefined, okay? Here we got 0 squared plus 1 squared equals to 1, true statement. And then we're left with 1 over 0, which is equal to, sorry, so this is 0 over 1 now, which is equal to 0. All right, so that is allowed. Okay, so let's jump over to question 6. Okay, so label the angles of rotation and the coordinate points around the unit circle. So this is a circle. Then use the points to help you fill in the blank. So we want to fill in um, these points. Okay, so this is a unit circle, right? So I'm assuming we're a little familiar with the unit circle. So right here we get that this is going to be pi over 4, right? And then my coordinate point there is square root 2 over 2, square root 2 over 2. Over here, we are at 3 pi over 4, and my point there is going to be negative square root 2 over 2, comma, square root 2 over 2. Let's make this more clear. Okay, so down here, we are at a 5 pi over 4, 5 pi, that's my theta. This is theta here. Theta, theta, theta. And then my point here is negative square root 2 over 2, comma, negative square root 2 over 2. And then last but not least, I am a 7 pi over 4 as my theta, and my point here is going to be square root 2 over 2, comma, negative square root 2 over 2. Okay, now that was assuming we knew the unit circle, right? If you didn't know the unit circle, let's kind of talk about this. So this here, the hypotenuse here, is 1. Why? This is 1. I'll just label this as 1. Now, these points right here, these lengths are the exact same, right? How do we know they're the exact same? Because this is a 40, 45, 45, 45, 90 triangle, right? So it can be x squared plus x squared equals 1. So 2x squared is equal to 1, x squared is equal to 1/2, x is equal to the plus and minus square root of 1/2. So is equal to 1 over square root of 2 plus and minus, right? Now I can multiply this by square root of 2. So x is equal to plus and minus square root 2 over 2. Okay, so that's kind of where I came from. Now we need to think about this a little bit more. Okay, so now cosine of pi minus theta. So that should ring a bell because we've been doing a little bit of that in the beginning. So let's think about this angle, right? So angle pi minus theta represents a counterclockwise rotation of pi radians, right? Minus this angle. So where does that place you? What quadrant? Right? So this is pi right here. It puts you minus theta. We'll call this theta right here. So if this is theta, this is theta right here, right? So then cosine here is what? Positive or negative? Let's bring the photo, not the photo, but let's bring this graph, this chart. Copy. So here we're talking about cosine. So cosine in quadrant 2 is negative, right? So let's think about this. So if I'm at cosine of pi minus theta, let's call this theta. What is my cosine here? Okay, it's going to be this value. But this value is equivalent to what? The negative of this. So then this is equal to negative cosine of just what? Of theta. Okay? Because what I'm telling you now is that pi minus theta, you're going to be in this quadrant 2. Okay? So if we were to use this, we know that this is going to be negative square root 2 over 2. So we can even write that. Right, but I'm not. I'm going to keep it more general. And then we know that right across to the other quadrant 1, it's just a positive version of this, right? So that's where it comes from, okay? Okay. I hope that kind of made some sense. Yeah, because we're subtracting theta from pi. So theta has to be positive, so we are going to be in quadrant 2, okay? So quadrant 2 here is just a negative of whatever theta would be here, okay? This is theta, this is theta too, okay? Okay, let's talk about 6. Let's label this, okay? So, I'm not going to label the angles per se, but we know here we are at square root 3 over 2, comma 1/2. Over here it would be where? 1/2 square root 3 over 2, okay? This right here is 0, comma 1. Now, what about right here? What's happening there? My x-coordinate becomes what? Just negative. Negative 1/2. What about my y-coordinate? It stays the exact same, okay? Now what about here, right? It becomes negative, but my y-coordinate stayed the same. My sign is positive, okay? Now here I am at negative 1, 0. Down here, what about there? Do my x-coordinates change? No, they don't. But my y-coordinate becomes what? My sign is now going to be negative. Good. This is kind of what I want you to start thinking about, right? Now here, my x-coordinate still stays negative, and my y-coordinate, sorry, this should be negative, is now going to be what? Negative, right? So this is negative square root 3 over 2. This right here is 0, negative 1. Here, now I'm positive x, right? So this x is 1/2, and my y is going to be negative square root 3 over 2. And then last but not least, right there, what do I get? I'm going to get positive square root 3 over 2, negative what? Negative 1/2. Okay. Okay. So now let's think about sine of pi. So this is pi right here, okay? Plus theta. So I'm adding theta, either this theta or this theta together, right? So one of those. So think about, what quadrant are you in? What quadrant are you in? If I'm adding pi plus an angle theta. So you should, the terminal side, so the terminal side is in quadrant 3. Okay, so that's important. We are in quadrant 3. So sine is going to be what? In quadrant 3, Sine is positive. Sine is negative. So this is the one we care about right now. Sine is negative. Okay? So that's going to help us think about some stuff. Okay? Now, um, if I am talking about, let's talk about this data right here. If this is theta, okay, my angle of rotation is coming from here. Okay, and why? How would I figure out what sine of pi plus theta is? So sine there is negative 1/2, and then look at this. We fly across, diagonally across. And what is, right? So what is it going to be? It puts you in a quadrant that is what? Diagonal, right? From where you are. So what do we see here? It has an opposite what? An opposite sign, right? So if we're talking about quadrant 3 here, this is equal to negative sine of theta. Okay, let's kind of see this with a different one. So now, if I'm talking about this is my theta here, let's just say this is theta, this entire thing, right? Well, no. My angle of rotation, if this is all theta, that means it comes from where? From here. So this is sine of pi plus theta is that. And if you fly directly diagonally across, it's just a negative version. That's all it is. Okay? So the sine of pi plus theta is the same as the negative sine of the reference angle. Okay? Okay. Now, let's talk about the graph of sine of theta to help you fill in the blank. Okay? So sine of theta is 2 pi minus theta. Okay? So I think it's important to realize that the period here of a sine function is just 2 pi. The period of sine is 2 pi. So the fact that we have a 2 pi here, let's just rewrite this as sine of negative theta plus 2 pi. Because does the 2 pi matter? Think about that. Does the 2 pi matter? Why does it matter? Why does it not matter? Think about it. I want you to understand that. So think about this as a negative pi. And if I keep adding 2 pi, I'm going to end up at the exact same what? At the exact same place. Okay? I'm going to end up at the exact same place. Okay? Adding 2 pi is essentially irrelevant, is basically quote unquote irrelevant. Okay, to Mr. Benya, to me. It's basically irrelevant because it ends up at the exact same place. Because it's back to the same quote unquote place value. Okay? So this is just going to be equal to sine of negative theta. Okay? Now let's think about if theta, sorry, not pi. If theta is equal to, let's say, pi, let's use this picture, pi. Okay? Then if I'm going to have sine of negative pi is equal to 0. Right? So the same concept. So now let's think about something different. Let's say theta is equal to right here. Let's just call that pi over 2. Okay? So then I'm going to get sine of negative pi over 2 is equal to, so negative pi over 2 is right here. So what can you see? It's going to be the what? The negative of it, right? So this is just equal to negative sine of pi over 2. So this is equal to just negative sine of theta. Let's go to number 9. So, this is pretty straightforward. Find the radian measure of the central angle of a circle of radius r that intercepts an arc of length s. Okay, so then this becomes a matter of just solving. So s is equal to r times theta, then s divided by r is equal to theta. So here, my angle measured in radians, I have that theta is simply going to be equal to my arc length, which is 11 over 35. And then they want us to round to 4 decimal places. So let's do it. So 11 over 35 is 0.3143. So equals to 0.3143. So here again, theta is equal to my arc length of 9 over 14. So then we go back here. 9 over 14 is 0.6429. 0.6429. Theta, again, here, my arc length is 28 over 16.5. And I'm left with 28 divided by 16.5, which is 1.6970. 1.6970. And then last but not least, 90 over 45 is just equal to 2. Okay, so that was pretty straightforward. Here we have these, right? These are just kind of these special properties that you should be able to think about. And then we did some identities here with the Pythagorean identity. And then we found values for theta, right? Good. So I hope you have a great rest of your day.